Alright, Bismillahirrahmanirrahim. Assalamualaikum and good day. Right, so in this lecture, we will look at introduction to function and some packages in R. Right, for the first part, let's look at introduction to function. So a function is a self-contained block of codes that encapsulate a specific task or related group of tasks. Means that we're going to pool all the tasks that we're going to operate in R, right? And then we're going to pull it into a function. So when we want to use it, we don't need to type or code all the ingredients to analyze the data, right? We just code one function to call all the steps or analysis that we required in the analysis. So a function takes some inputs, perform the task, and then send the output. So R comes with the numerous built-in functions such as mean, summation, we have a standard deviation, summary, and so on. There, all of that is called as function. It's a ready-made function. But in this lecture, I would like to show you how to code a function, how to develop a function for us to do analysis, right? So in function in R, it allow us to create your own function. It is known as a user-defined function. So we create our function known as user-defined function. So what is function actually? A function in R is a piece of code written to carry out a specific task. It takes some input and we're going to process it and return the result, right? So it help you to reduce your codes and redundancy to make analysis more easier, right? So there are types of function. First, we have a built-in function such as mean, print, summary, sum, standard deviation, and so on. And we also have a user-defined function. So user-defined function means that a function created by user for a specific task. That means that this is the objective of this lecture. We're going to define our own function in R. And last, we have anonymous function where the function without name used for a short task. Right, so why we use function? So there are three objectives basically because of modularity, reusability, and clarity lah. So modularity means we're going to break down the complex task into a smaller and manageable parts, mean that we don't need to create a long function, a long code to do analysis. We just call one function to execute the analysis. And then another one is reusability, means that once we write the function and we can use many times, right? In different data set also can, right? And then clarity, make your code more understandable and easier to maintain lah. Right? So anatomy of function, right? Let's look at the anatomy of function. In function, maybe we already look at the previous one, which is mean, summary, and so on. So a typical function in R has the following component. We have names, parameter, body, and return value lah. So there are four basic anatomy of function in R. So first, a name means identify the function and use it to call. So for example, we use mean data mpg, right? So that is the name of the function, and parameter is the value that we input into the function, right? Also known as argument. So the body is a code block that perform the task, and return value means we're going to once you already execute the analysis, we want to return the result and we want to display the result. So let's look at the simple function. This is basically the basic syntax of a function. So a function can be stored in R object. So this is a function name, and we start with the function name, right, which is function, and open bracket parameter. This is a parameter that we want to input, and we're going to start with the curly bracket, open curly bracket, and then we're going to input on the second row. We're going to input our codes to execute, and last to return the result and close the bracket. So the function name is the name used to call the function, and the parameter means the variable that we input into the function, and result is the output of the function. So now to understand this further, let's look at the example. Let's look at example number 1, which is adding two numbers. Right, so let's look at adding two numbers. Okay, all right, so now I want to add two numbers. Maybe I want to add 1 plus 2 equal to 3. So instead of typing 1 plus 2, this is very simple, right? I just want you to understand the concept first. Right, instead of typing 1 plus 2 equal to 3 every time, so I just need to use function. Let's say I put one object name add number, right, add number, and I call it a function. This parameter, I will input two value, a and b. Means this is the parameter value that I'm going to input. Maybe a is equal to 2, b equal to 1. So I want it to make it a summation, right? So a plus b, this is our operation to run. And then once we already write our operation, then we need to put return sum, right? Return the value. So and then we need to close the bracket, the curly bracket. So remember, once we type a function and the argument, we need to open the curly bracket, input our codes, and return the result, and close the report. The curly bracket means that the operation of function is done. So let me run this one. So I already done this one. So to call the function, to use the function, we just need to take some numbers. For example, add number. So we need to call the function. This is our new function, our defined function. And if you look at the array parameter or the argument that we require in this original function define, we need a and b. So it will take a plus b. So let's say we put 2 and 6. So supposedly 2 plus 6 equal to 8. So if you run, it will return 8. So we don't need to click type a plus b anymore. So basically this sounds silly because this is a very simple example, right? So to understand better, add numbers here is the function name, that we define. A and b is the parameter that we require. If user want to use add numbers, it should put a and b, where a and b is the value that we want to add, a plus b. And then when we add a plus b, we store it into sum, right, into sum. And then last part is we want it to return, to display the result, right? And then that's why if we want to use the function, we call the function name add numbers, and we input the parameter that required, means a and b. So a is equal to 2, b equal to 6. So a plus b, or 2 plus 6 equal to 8, and should got 8 lah. So this is very simple example, right? Now let's look at the more complex example. Example number 2, right? Calculating mean, median, and mode. Right? For example, I want to calculate mean, median, and mode. Right? So let's try to derive a data. So let's say I create a data. Right? Let's say I create data equal to C 2 3 4 5 6 7 8 9 10 11. Right? Contoh, for example, right? And then I want to calculate mean. So if you want to calculate mean, let's say I type the function mean data. I'm using a built-in function which is mean data. So this is very simple example. Let's say I create category, means I want to display mean of the data, right? should be equal to mean data, and then I want it to make some space after display the result. For example, this is a function, this is a built-in function, right? So calculate median, right? For example, median data, right? So this is a built-in function, right? So cat means I will just copy this one lah, so I just adjust one by one. So median of data, so I just put median data, right? Next, I want to calculate mode of the data. So let's say I create a function lah. In R, there are no ready-made function to call mode or to find mode. So this is a ready-made function or built-in function in R to call mean and median. Right, so get mode. So this is a function name that we want to define. So function data, and we open the curly bracket. Next, we're going to input our operation unique. So unique. So in the data, we want to create a unique. So maybe I need to change something lah here. Maybe to find the data, the mode. There in this data, there are no mode. So 11, 11, 12, 11. Right. So I think here we know that mode is equal to 11. So next, I'm going to use unique, and then I want to choose wish.max, right? And then tabulate match v and unique v, right? Okay, so this is the function that I want to call, right? Okay, now I already have the function, but this one is not yet finished because the mean of median, the mode of data is not yet presented, because I just created the function, but I not yet call the function. So let's say I can call mode data equal to get mode. So this is the function that I already created just now. Okay, right, get mode equal to data. All right, the parameter will be data, and then I put cat, this one I copy, I paste here. Mode of data is get mode, right? So it will present you the mode. Wait, where is the unique? So this one should be, oh yeah, this one should be V lah, because we call it V kan. Okay, now it will show the value. Wait, I think something wrong here. Yeah, I think this one, get mode is a function, right? But I already store it into mode data, so I just need to change it to mode data, right? I think this one should be okay. Yep, yeah, should be okay, right? So this is how we create a mode function for modes, right? This is our user defined function, and this is a built-in function ready available in the in R. Let's look at more complex example by looking at how to find mode, mean, median, and mode for empty car dataset. Calculating mean, median, and mode for empty cars data set, right? For example, so I'm going to create a function for mode first. Maybe I'm going to call this function function to calculate mode, right? So it's the same as example as previous. I think I just copy this one and put it here, right? And then I want to create a function already create a function, because we know that if we want to find mean and median, is already we have a ready-made function, right? So now instead of create one by one function, so what is the objective here is I want to create for the whole. I just create one function for all measures of central tendency. So now I want to creating main function to calculate mean, median, and mode for all numerical variables, right? So we know that if you want to use empty cars, all numeric, for example, this is initially all numerics. So I want to create a function stat empty cars, right? Function. So the parameter will be our data set, right? And then I'm going to open the curly bracket, and first step I want to put is to filter out non-numeric data column, right? Filter out non-numeric column. So maybe I type numeric data. It should be data set. This is the data set I'm going to call. So if later on we will replace it to empty car, so supply data set, and then is dot numeric. So it will filter out all the numerical data lah. And then we're going to apply function to each column, right? So first we want to find mean, so mean as apply. So since this is a data set, so we need to use as apply. Later on I will explain in next lecture what is apply family. So we have apply, s apply, t apply, m apply, and so on lah. So we will discuss apply family in detail lah. Numeric data, so numeric data is from here. We will select all numeric data when we call mean na.rm equal to true, and then we're going to have medians as apply numeric data median na.rm equal to true. And next we want to find modes, right? As apply numeric data, and then we're going to use mode, right? So get mode here, get mode should be mode here. We don't need to specify na equal to rm, na.rm equal to true, right? So this is for our operation. And then next I want to combine result into a list, right? For example, right, result, so I letak list, and then means equal to means, right? And then we have median equal to medians, and last is mode equal to modes, right? So this one I need to call all the result to be here lah, right? And then next I'm going to return the result, right? So this result will return into the output. So this one, if I call, so this is a good function. So if I want to use the function, use the function. So how to use the function? We're going to use from here, stat empty cars. So stat empty cars. So we're going to input our argument. The argument will be data set. Our data set is empty cars. So it will show us the result. So see, we already have the result. So if you put it into list, maybe now I think the best is to put into a data frame lah. Instead of list, I think I want to change it to data.frame. So it will present it into a data frame. So see, it already present it into data frame. So all the result currently, CYL is a numeric this is a original data, right? CYL is a numeric, so it will calculate the mean for CYL, median and mode, right? So let's say I want to change example number 6. So this is example number 3. Example number 4, I want to change or convert numeric data to factor variables, right? So if you don't get the codes, you can pause the video and try to copy the codes. Right now, we know that that empty cars, right? str empty cars. So some of the variables should be numeric and factor. For example, CYL, VS, AM, gear, carburetor should be in factor level, kan? So we want to convert this to factor by using function. So let you create a function. So let's say name as this is a convert factor. I name it is to convert factor, and then I put function, and then I want to make it general data set, and then I'm going to create a column name. So this is a column name that we want to convert to factor simultaneously, and then we create a specified column, right? So it should be names data set. So it should be tally. This data set should be in the data set lah. And then for column names, right? So we're going to ask R to convert it to factor one by one, right? So data set col, right? So as factor data set col, right? So this is the end of the for. So what happened here means that we already have the name of data set. For example, names of empty cars. Right? So we have all the names, variable names. So when we specify the names to convert, right, later on, it will find in the data set and change it to factor, right? And then next, don't forget your return data set, right? So that's all. So this is our function. Let's run this one to see whether is there any problem. Yeah, so there are no problem here. So we want to test the function, whether the function is work well or not. So let's look at str empty car at first, right? So all numeric, supposedly CYL, AM, VS should be categorical data. So we should use empty cars. I'm going to convert it to empty cars, and then convert. I'm using the function convert factor, right? So the first argument is your data set lah. I need to put empty cars, and then the data set that I'm going to the variable that I want to input is CYL, and then I should put VS, and then AM. Next will be gear, and last will be carburetor, right? So once I input into the function, then I can call str empty cars, right? So let me call this one. So see what happened here. So it is already changed it to factor lah, right? So means that our function is good and ready to go. So in just one function, we can convert it into a factor. No need to use to convert one by one, or to use for every time, right? So we can use a function only. So let's say I want to use I want to convert air quality. For example, let's look at air quality. For example, I want to change month to factor, for example. So I'm going to use convert factor air quality, and then I put month. right? So now str, oh wait, I think I should put str in front so we can see the structure. So now it's already changed to factor, right? So this is just an example, right? Okay, so I think that's all for creating a function, right? I think you can try to do it, but to make it understandable, right? Maybe we try to create another function, right? Another example, Example number 5, calculating mean, variance, standard deviation, median, and IQR, for example, right? So it's the same concept, right? So now I'm going to start with the stat calculator. For example, this is the name that I want to put, function, and then I want to use it as a data set, right? So now I open curly bracket and close, going to begin to create a function. So first function that I want to create is to find the IQR, right? To find the IQR, so calculate IQR. So calculate IQR, I create a function, and then v, so this one should be, function can be into the function, right? IQR is a ready-made function, right? NA.rm equal to true. So this is the first function that I want to create, which is calculating the IQR. And then next I want to filter out the numerical variable. So means that you know that when you want to create, filter out the non-numeric variable, you know that when we want to create mean, variance, and deviation, and median, and QR, it should be in numerical variable only, can? So numeric data should be data set, right? Supply data set is dot numeric, right? So this is to filter out the non-numeric. We just select the numerical variable only. So then we need to apply function to each column, right? So means we need to calculate mean as apply data set. Sorry, no, not data set. It's supposed to be a numeric data lah, numeric data. And then we want to calculate mean, and a.rm equal to true. Next, I want to create a variance, right? So as apply numeric data, right? Variance is a var in r, and arm equal to true, right? Next, I want to create a standard deviation as apply numeric data. So SD is for standard deviation, and a to rm equal to true. Next, I want to create medians, right? Median as apply numeric data, median, and a dot rm equal to true. And then we can create, I think we don't need to use IQR, right? Because it's a ready-made function. I can remove this, right? I can create IQR, right? As apply numeric data IQR and a.rm equal to true, right? Next, this is already nice. I already create a function there, maybe iteration there, the analysis, and then I want to create a data frame. Data.frame means that once I already have the values, I want to put it into a data frame, right? Result. So I'm going to rename this as a result right? Data dot frame, right? The first one is min equal to means, right? And then variance equal to variance. Oops, don't forget the comma. And then we have standard deviation, maybe standard deviation equal to SD S, and then second last is medians equal to medians, right? Remember, I just call back all the function that the value that I already calculated. IQR, right? IQRS, maybe this one I put it into a small letter case like IQRS, so can differentiate kan, IQRS. And then once you already pull the data, just return result, right? And then that's all. And then don't forget to close the curly bracket, right? So make sure this open, this is closed, and then we try to run it, and then this is good. And then we want to test the function, whether the function is work well or not. So we're going to use stat calculator, stat underscore calculator. This is, let's say you use empty cars, right? So we know that before that str empty cars, so this is the only numerical data kan, display, mpg, horsepower, drag, weight, qsag, right? So supposedly it will calculate only mpg, displacement, horsepower, drag, and so on lah. Right, so let's call this one maybe, yep, right? So run this one. So now it's already calculate it to us, for us lah, the mean, variance, the deviation, median, AQR for the variable that we already sorted, right? So that is a very simple way to create a function. So the thing that you need to remember is we need to have function, argument, open bracket, all the operation that we want to put, return result, and close the bracket, and then we can use the function that we already created, right? So that's all. So I think it should be okay. Maybe we can try another example. This is the last example, example number 6. Example number 6, maybe we want to detect missing values, right? Detecting a missing value. So example, we want to create a function detect missing values, right? So this is a function, and then we're going to put a data set, open curly bracket, and then we're going to put the operation here. So operation, first thing I want to find how many numerical data missing counts. So what can this function use is numeric and call data set. So in this case, what we do is maybe we change it to empty car so we can understand the function here. So it will return how many column, how many data that has a missing value, right? So now we're going to names missing value, missing count, right? And then we're going to put it into a call names data set. So this is a statement, first thing that we want to do. Let's say we want to create a for loops in 1 until and call data set, right? So since we want to use the for function, open the curly bracket, so missing counts, right? So this is I. So what we want to do is we want to sum all the missing value at data set I. So this is a operation that we want R to do. So calculate how many missing value in each variable. It is based on the column names, right? Next, we want to filter out the no missing value. That means that filter out columns with no missing values. So missing counts should be missing counts. Oops. So missing value should be more than 0 lah. Right? Kalau if more than 0, that means that it will show us the missing value, and then we return missing counts. Right? Okay, so this is the function that we want to create. Try to run this function whether it's okay or not. So now to test this function, right, maybe I create a sample data lah. Sample data. So data dot frame, maybe A, we have C1, 2, and put some missing value 4 and 5, and then we have B equal to C and A 2, 3, 4, 5, and then we have C equal to maybe 1, 2, 3, 4, 5. There are no missing value for C, right? So next I use the function detect missing value sample data. Right, let's run this one. Supposedly it will show us oh yeah, don't forget we have comma here because we try to combine all the variable into a data frame. So it will show us A, we have one missing value, B, we also have one missing value, right? So let's try another experiment with the real data, huh? So we know that empty car, there are no missing value for empty car, right? So detect missing value empty cars, right? For example, let me copy this one and paste this one. Yeah, there are no missing value. This is no missing value, right? So if you look at empty cars data set, if you look at this one, there are no missing value lah, right? So let's create a missing value. Let's create missing value for empty cars data set. So let's put it into object 1, data 1. So now I want to create a missing value for data 1. So let's say for column number 1, 3, 2, 3, and 4, row 1, 2, 3, and 4, I want to create for missing value for column number 5, number 4, number 3, and number 2. Right, so now it put as NA. Right, so now let's look at this one. So data 1 same as, oh, so maybe I change this one first. So data 1, there are no missing value, it's the same as empty cars. Let's say I create a missing value here. So I call data 1, there is a missing value here, right? So I'm using the detect function, so I change it to data 1. So when I want to run it, it will tell us the missing value. For CYL, we have 4. CYL, we have 4 missing value. Displacement 4, horsepower 4, drag also 4. Right. So this is good function. Right. Just one time construct, and then we can get the result. Right. So I think that's all for introduction to function. Right. So we will continue to the next one, which is introduction to packages. So this is going to be very simple and short lah, right? Alright, so let's look at this one. Introduction to packages. So a package in R is a collection of function. Means that if you have you want to create many functions, right? You can create a package. Means that you pull all the function into a package lah. You can in package also contain a collection of functions, sample of data, and documentation of how to use the function, right? By using a package, you can leverage your work of others to perform a complex task in just a few lines of codes. This is very good. So why we use package? To enhance our functionality, efficiency, and community support. So in a package, R package is come with a community support. It means that if you have a problem of using the function, then you will have the support from the maintainer, from the community, and so on lah. Efficiency means that it saves a lot of time and effort to pre-written and test the code lah, right? So it's already code is already stable, right? We just need to use it only. We don't need to create from scratch, right? So to install a package in R, right? So in R, as I said in first topic, right? So we have CRAN, which is Comprehensive Archive Network, and we also have our other repositories such as a bioconductor, and we can also get the package from a local file if you create one, right? You can also download the package from GitHub, Kaggle, and so on, right? Many sources can be download. You can download the package, but the most trusted package in R is CRAN, which is Comprehensive Archive Network. Means that the package is already reviewed by some reference panels to validate the package. For example, if you want to install the package, let's say you just need to type install.package and then we put the package name. So if you want to know where to find the package, you can go to cran.r-project and we can go, this is the website, Comprehensive Archive Network. You can go to the left hand side, find packages, and we look at the first statement. Currently, CRAN packages repository features 19,968 available package, and you can click on the table of available package and you can find all the packages inside CRAN repository. Right? For example, let's say I want to find random forest, right? So there are, if you click on Ctrl F, you type random forest, you know that there are 8 available packages named as a random forest. So maybe you can find random forest, the original random forest created by Bremen and Cutler, right? So this is the package that we want to use, right? So to install this package, we need to carefully look at the name of the random the package, which is random forest, capital F. Now I type install packages. I type a random forest and then I click enter. It will install it for me, right? So it depends on your internet connection lah, right? If it already installed, it will say that package random forest successfully unpacked and MD5 some check the download library package are in this one. This is the file, the folder that are store the packages, right? So or you can go to this tab, right, package, and click on install button, right? If you click on package tab here, you can see all the package available that you already installed. You can click on install and you can type the package name random forest. So by using this method, I think is more secure because R will help you to find the package name instead of typing one by one. So just type random forest and click on install. So the package, you don't need to install many times, you just need to install one time saja. Right, so for example, random forest. So if you look at this one, this is already installed in the R package. This is a Bremen and Cutler random forest for classification and regression. This is the version for this package 4.7-1.1. Right, you can also click on update the package, right? So you can update the package by click on update, so it will update the package lah. So once you update you click update, means that it will also ask you to update the package that require into the random forest, right? Means instead of in this package it require to use sampling package, RSQLite, HTML table, dbplier, and so on lah. So you can install, update the package. So if you look at this one, this is my already installed package version 2.3.4, but in update version we have 2.4.0. Right? You can click all and update, or you can click this one lah, select all or select something and click on install update lah. So I'm not going to do this because it will take some times, right? So to call the package or to load the package, once you already install, you need to load the package by type library random forest, right? Random forest. So it will call the library lah, means that you already load the library. For example, in this case, library dplyr, library dplyr. If you are not installed yet, you need to install first, right? And then call the library dplyr. Okay. Then using the package function, for example, you just want to use a specific function in the package. For example, this one, filter function from dplyr. So you just type dplyr ..:/ filter. This is a function, and then call the argument lah, type the argument. So it will in this example, I just want to filter the variable mpg that more than 20 in empty car data set, right? So by using dplyr package, use filter function. So or you can straight away use filter function, right? So provided that you already call the library lah, means that in this one I already call the library, so I can use the function directly. Okay, so that is about how to install, load the package, and using the package, right? So by this method, using the package without calling or loading the package by using dplyr ..:/. So if you look at question mark filter, right, or type help filter, if you look at filter document, it will show you if the function available on other dataset, other package, it will show you which one you are referring to. This is the first function, first package is dplyr, second package is stat. So if you look it into dplyr, you can click on dplyr lah. So you will get the documentation on how to use the function. Now, if I already installed the package, but I don't know what are the available functions in the package, so you can use ls get namespace. For example, I'm going to use instead of dplyr, is too many, random forest. So it will list to me all the functions available in random forest package, right? And of course you can check the documentation by type question mark or help lah, help package equal to random forest. So it will tell us, it will show us the documentation of the package. This is the list of all available function in random forest. Now you can try others, right? So I think that's all for the introduction to function and package. So I think we already finished chapter number 2. Next class we will look into chapter number 4, which is importing and exporting data set into R, right? So I will leave it to you exercise. So I'm giving you the exercise, so you can do it by yourself. Alright, so this is the exercise that I want you to do, right? I have 4 exercise question. So I want you to copy, pause this video and try to do one by one. So this is question number 1, question number 2, question number 3, and last is question number 4. Right, so I will also put all the notes in my website. Later on you can check the notes in my website. Right, so I think that's all for this video, this lecture. Thank you very much. Assalamualaikum.